This video is going to be about the idea of acceleration. Acceleration is the change in an object's velocity divided by the change in time. And the unit that we use to measure acceleration is based on that equation. Because velocity is measured in meters per second and time is measured in seconds, the unit of acceleration is meters per second, or meters per second squared. And the variable we use for acceleration is lowercase a. As an example of using this equation, we can imagine that a car speeds up from 7 meters per second to 25 meters per second, and it takes it 9 seconds to do this. To calculate its acceleration, we just compare the final velocity, subtract the initial velocity, and divide it by the time that it takes. So the acceleration here would be 25 minus 7 divided by 9, which is equal to 18 meters per second divided by 9 seconds, which is equal to 2 meters per second squared. So what that tells you is that the car is getting faster by 2 meters per second for every second that passes. So after 2 seconds, it's going at 4 meters per second. After 3 seconds, it's going at 6 meters per second. Acceleration tells you the rate of change of velocity, just like velocity tells you the rate of change of position. Because acceleration depends on velocity in the equation, it is a vector and can be represented with an arrow showing its magnitude and direction like this. And because acceleration is a change in velocity over a change in time, there are 3 ways an object can accelerate. So the first way is pretty straightforward. The first way is speeding up. The reason why that's an acceleration is obviously because the object is getting faster. It's changing its velocity. This is how we normally use the word acceleration in the real everyday world. If you say to your friend that you're accelerating in the real world, you probably mean that you're speeding up and getting faster and faster and faster. Your velocity is getting bigger. In physics, we also consider slowing down to be acceleration. We don't have any kind of word like deceleration or anything like that. We use acceleration for all 3 of these. So as long as you're changing velocity, even if the velocity is getting smaller over time, you are still accelerating. The third one is a change in direction. This one's a little confusing to students. Even if you are not changing your speed, if you're changing your direction, you are accelerating. And the reason why is that if you're changing your direction, the vectors of your velocity are changing. Because velocity is a vector, it has both magnitude and direction. So by definition, if you change your direction, you change your velocity as well. So that is a change in velocity over a change in time, even though your speed is not changing. So if you go around a corner at 20 miles per hour and you maintain 20 miles per hour the whole time, you are still accelerating even though you are not changing your speed because your direction is changing. Therefore, your velocity is changing because velocity depends on direction, and because your velocity is changing, you are accelerating. So this is a very common confusion that I want to address right off the bat, and that's the meaning of positive versus negative acceleration. Positive acceleration means the velocity is being added to in the positive direction, and negative acceleration means the velocity is being added to in the negative direction. Positive acceleration does not necessarily mean that the object is getting faster, and negative acceleration does not necessarily mean that the object is getting slower. It just means it's changing its velocity in the positive direction or in the negative direction. As an example, let's say that we start at time of 0 with a velocity of 20 meters per second and we have an acceleration of 5 meters per second squared. That means that for every second that passes, this acceleration is going to be added to the velocity. So after 1 second, the velocity is 25, after 2 it's 30, after 3 it's 35, and after 4 it's 40. Now let's do that same thing with a negative acceleration but a positive velocity. If you have a negative acceleration but a positive velocity, you're just going to add that acceleration to the velocity for every second, but what that means is that after 1 second, the velocity is slower. Now it's 15, 10, 5, and 0. You might be a little confused and think, okay, so this seems like negative acceleration means that the object is slowing down, but that's not necessarily true. Let's imagine that the velocity itself starts off negative. That just means that the object is moving fast in the negative direction. If you add this negative acceleration to that velocity, every second that passes, minus 5 plus minus 20 is minus 25, so this velocity is actually getting bigger and bigger in the negative direction. So the thing that tells you whether an object is speeding up or slowing down is whether the acceleration and the velocity have the same sign or the opposite sign. If they're both positive or they're both negative, then the object is getting faster. But if one is positive and the other is negative, that means the acceleration is taking away from the velocity and getting it closer and closer to 0. Like right here, the acceleration is positive and the velocity is negative. But if I add positive 5 to negative 20 for every second that passes, it's going to get slower and slower. It's going to go to negative 15, negative 10, negative 5, and 0. So that positive acceleration is actually slowing the object down. So one more time, positive acceleration only means the velocity is being added to in the positive direction. Negative acceleration means it's being added to in the negative direction. So if you could just copy down that common misconception and then the correct understanding in this table above my head. So that's everything that you need to know about acceleration. We're going to be working with it a lot this unit and learn some new, more complicated ideas about it, but for now, this is what you need to get started.